Now we're looking at just a little bit more complicated greater than absolute value inequality. What we do with these, again, is the same as what it was before with the greater than. The difference is that we have an expression inside the absolute value now. So we take what's inside the expression, the absolute value, and we write out the expression, 4x minus 3. We change the direction of the inequality symbol, so less than or equal to, and we make what's on the right-hand side negative, so negative 5. And one way to explain why we change the direction of the inequality symbol is that we could just make it the negative of both sides. So 4x, negative 4x plus 3, so the whole thing that's inside the expression. If we made that negative, multiplied it by negative 1, we would keep the direction the same and keep the sign the same. But essentially we're multiplying both sides by negative 1, which would change the direction of the symbol. And that way we can just use what's inside the expression for the absolute value instead of an extra step. And again, that's or 4x minus 3, keep everything the same, greater than or equal to 5. So again, what's inside the absolute value on the left, change the direction of the sign and direction of the inequality symbol and change the sign for the left-hand side, and then or, and then just what's there. 4x minus 3 is what's on the inside, and then 5 is what's on the right-hand side, and we keep the inequality symbol the same direction. So add 3 to both sides. We get 4x is less than or equal to negative 2. Divide both sides by 4, and we get x is less than or equal to negative 2/4, which is negative 1/2. Now we go to the other side, add 3 to both sides. 4x is greater than or equal to 8. Divide both sides by 4, and we get x is greater than or equal to 2. Now writing out our number line, we're going less than negative 1/2, greater than 2. So let's start with, let's say, negative 3, negative 2, negative 1, 0, 1, 2. We're starting with this part, which is x is less than or equal to negative 1/2. So we make a closed circle or a bracket at x equals negative 1/2. And then we're going to the left because it's less than or equal to. And now we'll go to this part, which is x is greater than or equal to 2. Again, it's inclusive, so we put a closed circle or a square bracket. We're going to the right. So here's our graph. And then in interval notation, we're going from negative infinity to negative 1/2, and from 2 to infinity. So negative infinity, negative 1/2 is inclusive, and that's or, so union, combined with 2 inclusive to infinity. And then we can check our interval solution by plugging in values that are in each interval. So let's use x equals negative 2. We'll use x equals 0, which shouldn't be a solution. And then let's go with x equals 5. So we have the absolute value. This is our check. We have the absolute value of 4 times negative 2 minus 3. What does that equal? That equals the absolute value of negative 8 minus 3, which equals the absolute value of negative 11, which equals 11, which is greater than or equal to 5. So that checks. At 0, we have 4 times 0 minus 3 inside the absolute value, which is 0 minus 3 inside the absolute value, which is the absolute value of negative 3, which equals 3. That is not greater than or equal to 5. So that checks because x equals 0 is not part of our solution. And then lastly, 4 times 5 minus 3 inside our absolute value, which is the absolute value of 20 minus 3, which equals absolute value of 17, which equals 17, which again is greater than or equal to 5. So that verifies our solution. So here is the graph and the interval notation for the solution to the absolute value of 4x minus 3 is greater than or equal to 5.